Good morning, good afternoon, good evening. Welcome to another edition of Ask an OpenShift Admin. I am Chris Short, executive producer of OpenShift TV. I'm joined by the main, host of the show, Andrew Sullivan, but we're also having our special guest, the one teammate I know that brags about his knowledge of DNS, Christian Hernandez. How are you today?
He is DNS man in.
Yeah, it's well, you couldn't have an episode about DNS without
you.
me.
I know.
Without me jumping on. Yeah, I'd be almost offended if you did.
Hey, right? I am happy that you are here today with us in person instead of just participating. I say just participating on chat. I think we do that to each other quite a bit, participating in each other's streams, just not actually in person. So hello, welcome everybody to the Ask an OpenShift Administrator Office Hour stream. So this is one of the Office Hour series of streams that we have here on OpenShift TV. And the goal here is really for you all, for our audience, the people who are listening and watching in, to ask us anything at any time about whatever it is that is at the top of your mind. So please don't hesitate to do that. We more than welcome those questions, again, whether or not it relates to whatever we happen to be talking about today.
We've already got a question.
Great. That's
well, not a question, but like interested in seeing the episode. So yeah, sorry.
Speaking of which, I didn't look at the staged YouTube channels to see if anybody, like last week, remember we had a question 4 days early. So
yes, we did not have that this time, I don't think. I haven't seen it at least. I mean, I always have the restream chat open, so I feel like I would have seen that, have popped by kind of deal, right?
So, all right. Well, thank you, everybody. Welcome. And again, please don't hesitate to ask those questions at any point in time. So today's topic, if you didn't see any of the social media or other things leading into today, we're going to be talking primarily about DNS and also a little bit about cluster networking, but primarily about DNS. And the genesis for this is Christian and I spend what feels like a substantial amount of time. I mean, relatively speaking,
it's a lot of time. Yeah.
Talking about DNS and DHCP. And DHCP, we think is starting to get out there, right? The requirements, the configuration, how it affects things, and all of that. But DNS is still largely a black box to folks. There's
a lot of folks,
there's
some of us might have read the RFC.
Yeah, well, understanding how it works and knowing how it works in OpenShift and Kubernetes is not the same thing.
Exactly.
And that's what we often see as a problem. So today we wanted to kind of look at, maybe demonstrate a little and explore DNS inside of OpenShift. And keep in mind that a lot of this will also apply to Kubernetes as a whole. So it doesn't necessarily matter if you're using OpenShift or not. Hopefully we'll be able to answer some of those questions.
DNS is a universal standard.
Yep. And it's funny because, I was an infrastructure administrator for a long, long time. And it was always the network's fault until virtualization came along. And then it was storage's fault.
Right.
And now that we've kind of worked past all of those, right, most folks are using either hybrid or all flash storage. Now suddenly it's back to being the network's fault, and a lot of times it's DNS.
Yeah.
Right.
Most of the time it's DNS. I have a nice haiku I could post.
I was going to say, where's the haiku about that?
The DNS haiku. By now, everyone knows that DNS haiku. Right? It should be. It's posted on people's walls, I would imagine. At this point.
I very seriously.
In my old office. Yeah.
Yep. I very seriously figured out how to put, or was looking into how to put up one of those little sidebar things like the news that just had an image of that haiku before we did this.
Oh, nice. Yeah. I think there's some software that does that. It's like a virtual camera and you can post things on.
There's a few of them. So before we get started, before I hand over to you, Christian, and start asking you a lot of dumb questions, there was a few things that I wanted to talk about. So for those who are regular watchers, regular attendees of our stream, you know that I like to cover a few things that I have seen either internally or externally that I believe are relevant. And also important things that maybe you haven't heard yet. So let me find the right tab here, which is always an issue these days.
Always the tabs. I've actually had very few open today. I just have a lot of windows.
All right, that's the one I'm looking for.
Oh, there you go.
So first and foremost, a bit of shameless self-promotion. We have been doing a weekly blog post after each one of our shows. They come out on Fridays. So this one happens to be from last week. If you missed anything from last week, not only do we have a link to the stream itself, but we also go through and try and put as many of the questions, as many of the things that we can find in there.
Oh, wow.
So if you want to quickly skim, because I know, one of the big things about doing a video stream is there is no transcript. There's no way to do like a control F and find a topic of interest. So I try to go through, I try to identify the questions and pull them out and then link to where they're answered inside of the video. So
nice.
These are better than our release notes. It's pretty good.
Right?
Yeah, it's awesome.
That was real dedication, right? Like,
yeah, it is. There's a lot of dedication. That's a lot of work. Yeah,
I would go that far.
Definitely kudos. So.
I gotta come on. There we go.
Yeah, that thing.
Zoom's little window gets in my way, and I can't.
I know.
Yeah,
I'm always trying to figure out how to move it, and I never.
It just needs to like I have 3 monitors, and it needs to just like go down right. Just get out of
here. Yeah.
So I will paste a link to that into the chat. The second thing I wanted to talk about is this is a bug that's been in place for a while. I had actually, you can see here, it was first reported back in September, late September. I actually had not heard or encountered this. I don't like to bring up bugs very frequently because, they happen all the time. So usually until it's something that I feel is coming up or more, I guess, serious or coming up more frequently than any generic old bug, I tend not to bring them up. So this one happened because I saw no less than 3 customers this week that encountered the scenario where their Vsphere IPI node had gone offline. So for whatever reason, the worker node was offline, right? Maybe it was turned off. Maybe the physical node had powered off, failed for whatever reason. And the IPI process is effectively reaped that node, right? It deleted the node because it was going to provision a new one to recapture that capacity.
Yeah.
The problem is that virtual node, the VM, had some PVCs attached.
Yeah.
And so the pod or the node was running, it had some pods. Those pods were using PVCs. Mm-hmm. The node failed for whatever reason. So it still had those VMDKs attached to it.
Okay.
And when IPI came along and destroyed the node, so too did the PVCs. Yeah, so that's not good. Data loss is never a good day at any point in time ever. So a couple of things to be aware of here. So first, and I'm scrolling down, yes, there's a number of missing comments in here. I apologize. I'm not logged into Bugzilla right now because there's customer information associated with these. So I don't want to show that information to the world. But there is a fix for this. I believe it was just committed yesterday evening or maybe early this morning, or PR'd rather. So it should be fixed in a coming release, right? Hopefully sooner rather than later. But for now, just be aware of, you might want to set that if you're doing auto scaling, if you're doing or using IPI and the autoscaler together to reclaim those nodes or to otherwise restore those nodes, you may want to configure the autoscaler with some sort of delay. So that way it will have at least 5 minutes. So that way in the event of node failure, the Kubernetes scheduler will say, hey, I need to clean these up and I need to move them.
Mm-hmm.
Yeah, give the scheduler enough time for those for the workloads on the node to move to another node before it reaps that VM. So
yeah, exactly. So another one, and man, I feel bad bringing up 2 bugs. That makes it seem like a bad week, even though
it's well, you know what? You can actually fill a whole show of just like looking over bugs.
Like you really could.
So, but how depressing would that be?
Yeah, that'd be a really.
So this one I've seen come up a number of times. Internally, especially, I've seen it come up a few times externally as well. Essentially, we have uncovered a inconsistent bug for CoreOS virtual machines deployed to vSphere using OpenShift SDN. So we think this has something to do with the VMX.NET drivers that are in the RHEL 8.3 kernel, the one used by CoreOS 4.7. And it's effectively, this manifests itself as some packet loss. So if you have upgraded to 4.7, or if you've deployed a new 4.7 cluster on Vsphere, and you're starting to see, 1, 2, 3, 5% packet loss, this could be the result of that. There is a workaround. I don't know, similar to the other one. I'm not logged in because there's some customer information here. There is a workaround. It doesn't look like it's in the public comments. If anybody needs that, just let me know. Andrew.Sullivan@redhat.com. I'll share that with you. Effectively, it's setting or turning off the VXLAN offload for the network adapters inside of the virtual machine. So it's just a couple of sys controls that you execute. You can test it by OC debugging, or you can use machine config to set them in a reoccurring manner.
Nice.
Okay, getting out of the things are broken, things are bad, bug reports.
Hey, we love failure. We love, helping folks, fix their problems on this channel.
Agreed.
General,
I try to, again, I try to preempt or try to make you aware of things so that way you don't accidentally stumble into a bad situation.
Yeah.
So the next one is a good one. I talked about sizing in a couple of different ways with 3 or 4 different aspects, whether it's sizing the cluster, sizing the nodes, sizing storage, right? All of those things across a handful of shows here on the OpenShift Admin Hour, or Ask an OpenShift Admin Hour. So recently, you see March 16th, Simon DeLorde published a blog post here that walks through application sizing principles. So a really good read, share this one with your application developer, application admin peers, that kind of walks through all of the different relevant settings, different capabilities, things like that, to help you size those clusters, both how the application is allocated resources and how those resources are then reflected inside of the cluster. And when I do the show notes for this one, I'll try and link those other episodes inside of there if I remember to make a note to myself.
Yeah. Also, your episode on resource limits is really good. Also to link there, because that has going from a VM to a container is very different, because the developer is used to getting 8 CPU, 16 gigs of RAM because of scale, right? Because, I need to be able to, now that's different. Now you're essentially constraining them. What do you mean I only get, half a CPU cycle? It's it doesn't completely work that way. So that episode, your episode of resource limits and ranges is good too.
I got the link right here.
Yep. Recommend those users watch that as well.
Drop it in chat here for everybody. There you go.
All right. So the last topic I wanted to talk about before we get started here is one, and we were joking before the show started that I'm just going to kick this hornet's nest because it's a bit of a sensitive topic, I think, internally, and I know that there are some people who are passionate about it externally as well, and that is reference architectures.
Oh, you just said a bad word.
I know. I'm sure if any of our marketing peers are watching right now, they all just had their stomach knot up because they're afraid of what I was just getting ready to say.
When you said it prior to the show, I was like, oh boy.
Ooh.
So reference architectures, for a little bit of background here. So anybody who has been keeping up with OpenShift for the last roughly 2 to 3 years, you'll remember that we used to publish reference architectures more or less every version or every 2 versions for various. I see somebody asked for the sizing link. It's the second one up, the sizing applications
right above the last chat.
Yeah, scroll up a little bit.
That came from YouTube.
That came from YouTube.
Yeah. I wonder if
I'll post it over there just in case.
Okay. So we used to publish reference architectures. Red Hat published reference architectures regularly. And we stopped doing that for a couple of different reasons. So the big one was quite simply resources, right? Constantly trying to and having, devoting not just the people resources, but the physical resources and all of the things associated with going through and generating those documents was, quite frankly, hard. And it really was. And invariably, it always led to, if we used one partner's, set of resources instead of another partner's, right? Sometimes there would be, hurt feelings and stuff like that. So it became a bit overwhelming in a number of different ways. So the decision was made, rather than creating reference architectures, which the perspective was, and I would be very welcome to anybody's additional thoughts or perspective on this. But the perspective was that most folks read a reference architecture not to literally implement it as written, but rather to glean, right? Rather to determine what information is important, what information is relevant, what decision points do I need to know to deploy an OpenShift cluster in my infrastructure. So it was really, for lack of a better term, right? It was a guide, right? It was a consolidated source of documentation for here's one way of producing an OpenShift cluster. So the docs team took upon themselves to take all of that knowledge and put it directly into the documents. So if we look at, can I type here? No, my browser is beach balling on me.
Oh, it grayed out and everything.
Oh, it grayed out. There we go.
Okay. There we go. All right, it's back.
So if we look at the documentation here, we scroll down to, for example, this scalability and performance section, you can see that, and this section has grown with each release. They are doing exactly that. They're taking as much of that information as they have, as they can get, and putting it directly into the documents, right? Recommended host practices is a great one. And allowing you, our audience, right, the people who want to ingest those reference architectures, to really understand the rationale behind those decisions, right? Not just, oh, I see that, in the reference architecture, they said, this value to X. Well, why? Why was it set to X? Sometimes we explain that, sometimes we didn't. So through the documentation, the goal is to provide all of that background, all of that information, so you can make the right decision for your infrastructure. So with that in mind, however, we didn't completely abandon reference architectures, right? It seems that way. And some of you may be thinking, well, I have seen some reference architectures come out, and you are absolutely correct. We now rely on our partner ecosystem for those. So I'm going to post this blog post into the chat here. So this one, which is coming up on a year old now, I assume Dave will probably update it. And I've known Dave for a few years now. He works over on our partner team, right? They do a lot of the reviews of these types of things. And the goal is him and his team work with, for example, if we scroll down here, right, Cisco and Dell EMC and Hitachi and HPE and so on and so forth.
Everybody.
And those partners create the reference architecture, which is then reviewed and contributed to by Red Hat. So if we were to look at, and I'm going to pull up one of these, right? This is the Hewlett-Packard Enterprise, the HPE site for OpenShift reference architectures. I'm also going to paste this in here. So if you are using HPE hardware, and let's say you want to deploy OpenShift onto your DL whatever servers, right? DL 380, well, I don't even know what the current gen is. So we can click on this 4.6 GL and DL, and it walks through all of the different components of their reference architecture. This is all created by our partners.
Yep.
So they still exist. They're still there. They're just not created, not published by Red Hat.
Red Hat, yeah. It's at the vendor that you're trying to put OpenShift on.
And that intuitively makes sense, because being a software vendor, Red Hat, like we really can't recommend hardware, because there's just like a ton of hardware that we're supported on. Like Andrew was saying, we don't have enough people to go out and buy every single hardware and vet everything, every possible combination. So we lean heavily on our providers like HP and Dell EMC to do these, right? And we can review them. That seems to be a better use of our time, rather than trying to build a team with an impossible task.
Yeah, exactly. And together we are stronger, right? So
yes, exactly. I just thought of that Simpsons episode.
Yeah, I was thinking of the exact same thing. It was the one where they mimicked Lord of the Flies.
Yeah. Yes, exactly. That's great.
So I happen to click on HPE over here. You see NetApp and Cisco have one for FlexPod. NetApp has one for their, NetApp HCI. There's literally dozens of partners that do these. Now you will see one exception to this, and that is OpenStack, because Red Hat is, Red Hat OpenStack. We create a reference architecture, and actually it's one of the or two of the folks on our peer team, the field product. What are they? Field product managers. FPMs.
Yes.
FPMs.
August Simonelli, Resox, and him and company, right? So they create that OpenShift on OpenStack reference architecture, and that's because it's a whole Red Hat stack there. Just like if you were to similarly, and I think I've said this before, CNI plugins, CSI plugins that come from partners, we don't document those inside of the OpenShift documentation. We rely on the partners for those. The exceptions being if it's Red Hat virtualization or Red Hat OpenStack platform, those are documented by Red Hat because it's a wholly Red Hat solution. And that's all I've got. These other tabs are for our topic at hand. So I will. Wonderful. I will now stop pontificating about things unrelated to DNS, and essentially, I'm going to start off. I'm going to play the role that I was born to play of dumb guy. So,
wait, that's my job.
We can share.
Well, we
can share.
We can all be dumb
together. Okay.
So Christian, you and I started this conversation last week or maybe the week before, and really it came out of some confusion around how does DNS resolution happen for OpenShift. And it turns out that this is a little more complex than you might expect. So can you elaborate on that and talk about, DNS in OpenShift and the difference between node-based DNS and pod-based DNS?
Yeah. So where do I start? Right. You know what I mean? With DNS. So I originally I was going to start like in the beginning, what's DNS, but I imagine that at some level, since this is Ask an Admin, there's some fundamental understanding of what DNS is, right? So DNS and kind of sort of what it, how it works from a high level. So I'll start with the fact that I guess you guys all know how, what DNS is, what the root servers are, what authority, server authority is, and all of that stuff. So DNS in OpenShift is kind of a layered design, right? So originally DNS in Kubernetes. So I think I'm just going to start there, DNS in Kubernetes and what it's used for. Then I'll work my way up. And so DNS in Kubernetes is used for service discovery, right? So this is it turns out DNS, that problem of service discovery was solved a long time ago with DNS, right? There's been a lot of software that's tried to do service discovery, people writing service discovery, and in the end, it just turns out like DNS was the
so what do you
what's the answer?
Pause there for a moment. What do you mean by service discovery?
So by service discovery, meaning that as an application or as a service inside of OpenShift, Kubernetes in general, it can reference a service by a name. For example, I have a front-end web, give a stupidly
label.
Dumb, two-tier application, right? I have, Node.js front end and some sort of database backend. I want to be able to just say database in my application, and it should just work, right? I shouldn't, me as a developer, or even as like an admin or as an end user, I shouldn't have to care or memorize IP addresses or what the IP addresses are or how to connect to that. So it should be as simple as just saying MySQL, right? Or database or whatever name you decide to deploy your database as. So that's the idea of service discovery. I can reference something by name and it automatically knows the IP address. So, and essentially, funnily enough, DNS is a perfect software to do that because that's just what it's been doing. There's, and that's what originally, it was the original intent right, for Kubernetes service discovery. So in Kubernetes, that's kind of like the bare, the kernel, the core of the use of DNS inside of OpenShift.
Yeah. So pods are deployed that represent some microservice, right? Front end, back end, database, whatever that happens to be.
Yep.
And then they have quite literally a Kubernetes service in front of it that says, point to these pods, and it discovers those IPs using this front facing, right? External facing, external being still within the cluster, but DNS name. So that other components can say, connect me to front end, and the service translates that into the set of pods, the set of IPs for the pods that represent that front end microservice.
Correct. Yeah. Okay. So it you can just reference things inside the cluster in general by a name, right? So it's essentially, you can even connect to other pods in by name, right? So everything is managed and everything has a name, and that's managed by the internal DNS server in Kubernetes, right? So before that was based on kubedns. They've actually upgraded a while back to core DNS.
Yes,
right. Which is
originally it was Sky DNS. I
remember Sky DNS, and then it was kubedns.
I remember compiling Sky DNS, and the very first time I deployed Kubernetes in like the 0.8 days.
Yeah, right. Exactly. It was like Sky DNS. It was also bare bones, dead simple, right? And so I like. Let me. Where am I here? I was going to share my screen a little bit and kind of go over the docs a little bit. So let's. If I can only find. There we go. The button share screen.
Mm-hmm.
Make sure it's the right screen.
Wherever you threw it, now you need it.
Yeah, wherever. Yeah, exactly. Now I need this little. There we go. Can I? Oh, I can move it. I'll move it over here. How about that?
There you go.
Way over here on the right side.
Way out of the way. Yeah.
So DNS, right? So I will. What's funny about searching for DNS on the OpenShift docs is that it's like not the first one. There's the API reference networking, right? So it's under networking. That's how I remember how to get to it. And then there is understanding the DNS operator. So OpenShift deploys core DNS via an operator, right? And so let me make this a little bigger because there we go. I can make it bigger if you like. Is that too big? No. Okay, 110 seems good. So we can. You can actually.
If you need it bigger, let us know, please.
Yeah, just let us know, right? Yeah. You can essentially copy pasta this. Let me make sure I'm at the right cluster. Vsphere. Okay. I upgraded this last night. Okay, so it looks like the upgrade went okay. Not that it shouldn't, but you never know.
It's very reassuring of you.
Yeah, right.
Right. Yeah. Thanks. The DNS
so if you go, yeah, exactly. See, I said DNS. I didn't say OpenShift.
Oh, Lord.
So this is it shows the DNS operator, and just like all things in OpenShift, it's controlled by an operator. So we have a DNS operator here, and you can see the version here, and that's all good. So what's really cool about this here, when you describe here, it'll give you information about your cluster. And so the important information is this information here. So the DNS service for Kubernetes runs on the service address, right? So the service address, from a high level, I guess now I could play dummy to you. Ooh, Andrew.
Yeah.
Is an overlay network. For the most part, it's an overlay network that sits on top of your regular network, right? A software-defined network. It's possible, but this will get. I don't want to rabbit hole too much, but it's possible to have Kubernetes running without an SDN. If you ever did Kelsey's Hightower's Kubernetes the hard way. He shows you how to do that.
It is hard.
It is hard because anytime you add a node, you have to add the routing table to all nodes, and it just makes sense just to use a software-defined network. So this is an overlay network. So when you see this is my service overlay network, and my cluster domain is cluster.local, which is the default. So cluster.local is the domain for Kubernetes, the internal domain for Kubernetes.
And so let's take a step back for a moment. So the core DNS service inside of OpenShift is for pod resolution, or more specifically, service name resolution for pods.
Correct. Service name resolution for pods.
So this cluster.local is meant to be only for internal resolution and has no bearing or no importance with, for example, the name of your cluster, right? So whatever your cluster name happens to be, mine is usually, like something.work.lan or whatever that happens to be. Nor does it have at this stage anything to do with your upstream DNS servers.
Right.
At this stage, no, we're at the pod service. We're at the service level because that's where DNS, core DNS really shines, right? It's the at the service level.
Yep.
So,
and then just a quick aside, that cluster IP that you see there, the 172.30. So that IP address will come out of what you define as the service IP range in your install-config.yaml. So if you change that from the default, you could see a different IP there, and that's perfectly fine.
Yeah. So it gleans that information from the range you give it, and it'll take that information and then it'll create this IP address. So, and this is the DNS IP for your pods, and that's the cluster domain. So one also quick thing before I actually just drill down into the pods is the cluster.local is you shouldn't name your cluster, OpenShift.cluster.local. Like that's you'll have really bad time.
Yeah,
I don't even think
anything .local. Anything .local.
Essentially anything .local. So that actually came up with some customers because they've had like .local domains. So Kubernetes has essentially ruined that for everyone.
So we have a question, Christian.
Sure.
So Sonics. So how does this talk to the router?
How does the service talk to the router? I'm assuming.
I'm assuming core DNS and the DNS operator.
There you go.
Yeah. So I'm actually going to get to that workflow. So I imagine you mean So, but in general, the service the service layer is a non-routable layer, but that doesn't mean things can't get in and out. So, but I'll talk about that workflow in a bit. So then this is the IP address for the DNS service inside the service name, right? So if I go back to the docs, and that does a describe, and this gives you a nice JSON path.
There you go.
Yeah. I've never seen that dollar. Interesting. If anyone knows JQ, let me know what that dollar does. So that's the service network range. So as Sully was talking about, this is the range, and that matches this IP here. Let me clear it. I always like to clear it because people don't like looking at the bottom. I know I hate it when someone's sharing their screen and I'm like, can you clear so my head could go up?
Yeah.
Yeah. So before I wanted to go through this doc line by line, but I think I'm going to skip around a little bit because it just makes more sense, right? So the core DNS has a configuration, and so and this is stored in a config map, right? And by the way, Andrew and Chris, I can ramble all and on, so please give me time checks so I can get to all the points I want to get to. And so this is the configuration file, right? So if you do that, I hate this manage fields. I can't wait to Kubernetes.
In 4.7 in the GUI, it automatically collapses those. In 1.21,
I guess, which would be OpenShift 4.8, it'll take take out the managed fields.
Mm-hmm.
You have to specifically ask for them. So this is the configuration file for core DNS. It's pretty simple. It first gives the domains it's the authority for, and then it even gives an ARPA for IPv6 as well. So
Nice.
that's something our customers ask for is IPv6 support. So it'll send information to Prometheus, so it has that plugin already set.
Mm-hmm.
And then it has this line here called forward.resolve.conf. So let's explore that a bit. So so all the pods have their resolve.conf set to, let me describe that again, to this IP address, right? So that's .10, right? 172.30.0.10. So let's get some pods. I know I have an app running here. There we go. Test. This is MySQL. OC-n test RSH. This guy. And then do bash, because for some reason SH, everyone likes SH. Command not found, clear. Okay, well, bear with me. Can I do this? Yes, I can. Okay. And so
it's about to say Control
L. Yeah, Control L. Like, that was Control L, by the way. You guys didn't see that. If I do a cat Esxi resolve.conf, it has a search field, right? So this search field breaks down pretty easily. First, it does the namespace.
Mm-hmm.
Right, so the namespace is a part of the DNS. So it says, anytime you do a lookup first, look up the name from this domain, then this domain, then this domain, and then finally this domain, right?
And that last one is your external, correct?
Yeah, this one is external or my internal, but to OpenShift external domain.
Mm-hmm.
It so if I try to do I have dig? No. NS lookup. Do I have ping? This is a very small container. So if when it is host on there? No, this is a very small container.
Dang, okay.
I think this is Alpine.
Okay.
But it does a search, right? If I do like an NS lookup of foobar.test.local. Oh, sorry, if I do a foobar, it'll automatically tack this on, look for that, then tack this on, look for that, and then it'll go down that side. Then it has the name server for this pod to that. The DNS, the internal DNS server inside of OpenShift. So it says 172.30. So it'll look up, this is its main DNS server, and it's the only DNS server this pod has. So it'll only ask the internal DNS server. So what happens if this pod tries to reach outside the cluster? Right. So what if I try to do a ping of like dns1.ocp4.cloud.chx, right? Or if I do a ping of google.com, how does core DNS handle that request, right? And so the answer was in that other, where's that YAML? The answer is in the next line, right? So it said, okay, well, forward everything that I don't know about to the host resolve.conf file. And in the host resolve.conf file, look for everything sequentially, meaning check the first, second, third, fourth.
1, 2, 3, 4, 5, 6.
Yeah, exactly. And so so in the pod, it sends everything to that DNS server. So that's first and foremost, that's the only config in the pod. Mm-hmm. And then the core DNS server will then say, okay, well, I don't know this. I'm just going to forward this onto my host resolve.conf file. So let's take a look at what that looks like. Oh, this is a Windows server. Interesting. Okay, OC debug. This is a server that I hack on for Windows containers, by the way. So hopefully no blue screens here. So this will so now we're basically remote shelling into the
cluster,
the node
right?
Here.
Yeah, that one node. No.
So I do chroot.
Christian, just to I answered in chat already. So another question: how do you change the order of name servers after the cluster has been installed? And hopefully our answers align.
This will be interesting.
What did you answer? And I'll say yes. So I would, changing the order, I would put it in, like in the machine config, or if you're using DHCP, just change the order in DHCP.
Mhm.
If you have a particular name server you want to connect to for a certain domain, I would use Core DNS's plugin feature. And like the only plugin feature that we support right now is forwarding, and I'll go over how forwarding works in a bit. So,
yeah, that's in line with what I said. I just didn't do the machine config part.
Yeah. Well, the machine config, if you want to just actually change the order on disk, or DHCP, right? Like if your DHCP is handing out your name servers, then just change the order there.
Yep.
And next time the lease happens, it'll flip them. And so yeah, so here I'm in the node, and if I do a cat Esxi resolve.conf, notice it's I'm using nm state, right? And so here it'll choose this name server, then this name server, then this name server sequentially, right? You'll notice that the first entry is my IP address, right? So I go to IP adder, right? Is it? Where is it?
That's a lot of interfaces.
Yeah, well, if you an OpenShift,
it's all the pods.
Yeah, it's all.
Yeah, it's all the pods, right? Yeah, it's all the virtual interfaces like this one.
That's like you do a find.
It's their line 11.
There you go.
Oh, it's
interface 11.
I'll just do that. Yeah.
Hey, what do you know?
So yeah, there you go. So so this is for the host file, right? So it'll look in the host file first, then it'll do DNS1, DNS2 in that file. So that's how that configuration works. If I go back here, it says forward everything I don't know about to the resolve.conf. And then it'll use those name servers as well. So
very cool.
There is a few things I want to. So here, right, it tells you operator status. You know, you just describe it and just kind of see. You know, it was degraded because I did earlier because I was doing an upgrade. But that's, and then the logs here in the DNS operator. That'll give you information about the logs. So one thing to note.
We have a question, Christian. So from Fahad. For vSphere IPI, does the DHCP server have to provide DNS records for the nodes? And I think what that's asking is, does DHCP need to do dynamic DNS updates with the DNS server?
So I'm going to say soft yes, it has to. There is a way to provide DHCP for only the IP addresses and not DNS. That gets a little laborious, I would say, and I would recommend using the DNS Forwarder for configurations like that, and I'll explain that in a bit. So the DNS Forwarder, it's probably the catch-all for a lot of these use cases.
And I'll add on to your responses saying, I don't think it's required, but it is strongly encouraged. And that is specific to on-prem IPI. So the on-prem IPIs use MDNS for their local node resolution. So inside of the cluster, it will resolve those IP addresses without an issue because it's using MDNS for that purpose. However, if you wanted to do external resolution, like you saw Christian a moment ago do an SSH, I think, maybe it was a debug. But if you wanted to SSH to that node, or you needed to have, like, you're exposing a node port and you wanted to reference that by name, DNS name of the node instead of IP address, then you would need to have external DNS have those node names, which is where that DHCP updating DNS would be recommended. But as far as I know, with on-prem IPI, so vSphere, Rev, etc., they don't need node names in external DNS. I'll also add on that if you do have DNS names and they're wrong or they are different, the nodes will actually take those names and use them instead. reverse DNS will override the name that's given to it. And just a time check,
DNS,
Christian, we got 15 minutes.
Yeah.
Okay, cool.
Take care.
So thank you. So here, the DNS service here runs as a stateful set. Not stateful set, daemon set, I think. Yes. So daemon set, meaning, it'll, I actually have 7 nodes. One of them is a Windows node, but the stateful set selector is set to OS Linux, right? So if I do a
daemon set.
Sorry, daemon set. Stateful. I was working with something else with stateful set, and I have stateful set on the mind. And so yeah, so that I have 6. So there's a daemon set does 1 pod for each host that's added with this label. And it's running in every cluster, right? And you notice that there is 3 containers per. So let's do a describe on that. Describe pod. Yeah, what are you describing? You should know. you should know what I want.
It should just intuitively pick that up, right? Like magic.
Yeah, I should just know what I want.
I can read my mind, right? It's Kubernetes.
Well, there was I used to work with a guy who would make a lot of typos, and I always hear him tell the computer, right? Because we always yell at our computers. Right. It's like do what I meant, not what I said.
Have intelligence. No, wait.
Yeah, exactly. That's what you tell your children.
Do as I say, not as I do.
Right.
Yeah. Don't. So the container that I wanted to call out inside the pod is the DNS node resolver, and its job is essentially to manipulate the Esxi host file, right? And so if I do a what is that, RSH, and I think that's on the pod hosts. No, it's not here. So its job is to basically manipulate the Esxi host file on the pod. And so notice this has like the IP of the pod. So this is my IP meaning the pod's IP address, and all the possible names that's associated with that. And that's what the job of this
what's in your resolve.conf
for that
on the pod.
Yeah,
I know we looked at that a moment ago, but just to compare.
Yeah, so it has the DNS server, right? So it doesn't have to go and look for the name for like the pod itself, right? Because it has that entry in Esxi host. For anything else, it uses that DNS, and if it doesn't find that, then it just forwards it on to the Esxi resolve.conf file on the node. So the last remaining 5 minutes, let's take a look at, I've been promising the DNS forwarding.
Yes.
Right. So core DNS, if you look it up, a core DNS, let's look that up. There it is. It says, I was reading this the other day. It was like a Y or something like that. Yeah, plugins, right? So it's a it has the ability to do plugins, right? So it's essentially, core DNS was made to be extensible. And one of the things, so just beyond name resolution, one of the things is that forwarding is written as a plugin. And you do that by editing the default configuration. So let's take a look at that here. Without the $, who put the $? There? They're copying that. I'm going to tell docs. Okay. So here, essentially, yeah. So essentially here, let's do this. Okay, so it's not there. Spec. We're deleting use spec and adding these here. So here you're plugging in DNS saying that, okay, so anytime someone looks up food.com, instead of going through that whole chain, right? So let's kind of recap the chain. The pod looks at its Esxi host file locally. Then it looks at its own resolve.conf. If it can't find it, it will then forward it to the resolve.conf file on the node itself. So instead of doing that, the pod will then the core DNS, when the pod asks core DNS, it'll say, well, for any domain foo.com, I'm just going to forward that request to these DNS servers. So this is I ran it in my day. I ran cluster DNS server sprawled up for my company, sprawled across all over North America. So sometimes you do DNS delegation, sometimes you have, for whatever reason, tech debt, dumb reasons, or when we say $ reasons, you have a DNS server that's kind of isolated from the other ones that they don't know about each other. So if you have stuff out there that you want to reach out to, you may have to ask that DNS server. And this is essentially an array, right? So I say foo server, the zones, right? I can put BAS, right? Anything under BAS, and use this DNS server. What I find cool about core DNS is that you can specify a port. You can't do that in bind. Bind, everything's on 53. Well, bind you can listen, but the client can't ask on other ports. So, and then the bar server, you have bar example.com, forward it to these DNS servers. So in this configuration, then once, if core DNS, then it kind of injects itself in the middle. If core DNS can't find the name, instead of forwarding it to resolve.conf, it'll try these servers. And then from there, if it doesn't know, then it'll forward it to the resolve.conf locally. So this is a way to, add different DNS servers in your cluster, right? So as opposed to the core upstream one from your resolve.conf file.
So I have a question for you, Christian, as well as there is a question from Ayman. So I'll ask mine first because I think it'll be a quick one, which is core DNS, right? The OpenShift DNS service also applies to static pods that are deployed. So for example, the etcd pods on the control plane.
Correct. Yeah. So that the static pods also get because they take part of that SDN, right? Yep. So they'll get that same configuration.
Yep. So the 5-second version is effectively for pod resolution. So if you're in a pod and you do a dig or an NS lookup or something like that, it first looks at its host file. It then looks at its resolve.conf, which will point it to the core DNS pod, which is it's a service that's going to be running. There's a pod on every one of the nodes in the cluster. And that will then look across all of the other services and the forwarders that are defined in this DNS config that you have up here before finally looking to the resolve.conf at the node level. So if it is trying to resolve something external to the cluster, you need to make sure that that resolve.conf on the node is configured correctly, right?
Correct. And then also one last kind of thing to interject there. The host is the node's host Esxi host file also does come into play in that same layer as the resolve.conf file, right? So it'll we're looking at the host resolve.conf file, that Esxi host there also comes into play. So
the question from Ayman, can I install OpenShift API across multiple network zones? For example, one for control plane and one for workers.
So you know the answer to that.
I do.
The answer the answer is for IPI today, unfortunately, no, because of how Keep Alive D works. The way we have it configured is that it requires layer 2 adjacency. For it to work, right? It is possible to configure Keep Alive D to work across on layer 3, but that's not how we configure it, and that's beyond the scope of support currently.
Yep. Yeah, I have nothing to add to that. You've seen me answer that like 400 times, and
I
know you've answered it too. So
it should be a bot, right? It should be
maybe I should make one.
You should have that regex. Yeah.
So Fahad, another question: can OpenShift span multiple ESXi clusters on the same vCenter when using vSphere IPI?
That's an Andrew question.
So that is on the roadmap. I know that technically, if you were to look today at the documentation for like the in-tree provisioner and all that other stuff, you can create the vsphere.conf and have it understand multiple clusters and all that. So we've had a number of customers that are asking about this. We did some internal testing. We found that it mostly works with 4.6. I think they were like 95% success, but they found a few things. They created issues. There is a Jira issue for it. I'll have to dig up the Jira issue. And if I can do that in the next 4 minutes, I'll post it in. So not yet, but multi-DRS clusters is something that is on the roadmap.
Cool.
That sounds cool. So
another question for you. Yeah.
Mm-hmm.
So set up DNS forwarding on my home lab, which works great. If the upstream DNS server becomes unavailable, the authentication cluster operator goes into a degraded state. Any reason for that?
So the authentication cluster operator. So so first and foremost, I'm gonna need more information at that, or like dig into the why that would be. So before I go into my long-winded answer, for my short-winded answer is I don't know. But I've had issues. So usually the authentication cluster operator being degraded is a symptom of something else, right? And so I've always found some weirdness with the router. So if you have like a router operator, I would look at the router logs. I would look at the authentication logs. I would look to see there might be a breakdown of the DNS chain at that point. The cluster, the authentication cluster operator probably has the upstream, quote unquote, upstream DNS name like OAuth cluster name .example.com, and that's probably in the pod. And since it can't look that up, it's probably breaking down. I'm just guessing at that point. Right, is what's happening. Yeah, such host. Yeah, see, look there. So if you're watching this and not looking at the chat, if you look at the chat, it says no such host. That's your external lookup, and I think that's what's failing. The health checks for the external lookup.
Yeah, I think the authentication operator relies on the quote unquote well-known endpoint to certify that it's talking to the right thing, and I think that connects externally through a node port.
Yep.
So it looks up the node name, which it's relying on that external, right? Those aren't stored in core DNS. Those would be in either the upstream DNS or in that MDNS responder, depending on your installation type. So I think that's why that's happening.
Yeah. So we're just assuming. Yeah. So, we got 2 minutes. Nice.
Yeah. Less than technically.
All right.
So Monster Frames facing an issue.
I asked him to join Discord, by the way, and ask him there.
Yeah,
so
or
I don't think we can tackle OpenStack right now.
No, I am not an OpenStack expert by the stretch of anybody's imagination. So please,
Chris doesn't have the cycle to answer.
Yeah. So please follow up on either Discord, or you're welcome to send me a message, andrew.sullivan@redhat.com, or if you want to send me a message on Twitter, Practical Andrew. And I'm afraid to say that I believe my direct messages are publicly open, so you can reach out that way.
Mine are definitely open. Chris Short, 2 S's. Feel free to DM me on Twitter too.
Yeah, and we'll connect you with the right people. We'll get an answer for that. So don't hesitate to reach out. So Christian, my apologies. Any last minute closing thoughts in the last 45 seconds or so?
Yeah, so it's really I posted a link to the docs. All I can say is just if you're having trouble with DNS, just follow the chain and see where you're falling down.
Yeah.
So many times, people blame DNS when it's not DNS, where DNS is a symptom. So it's good to always troubleshoot with the OSI model.
We had one of those.
Even in Kubernetes.
Had one of those this morning.
Yeah.
So. So thank you, Christian. Really appreciate you coming on today. As always, it's a pleasure to have you. Appreciate you sharing your knowledge.
Fun. Thank you.
So for our audience, thank you for joining us today. As I said, please don't hesitate to reach out at any time with any of your questions. You're welcome to contact me directly via email, andrew.sullivan@redhat.com, social media, Practical Andrew on Twitter. Christian, do you have social media or other?
Yeah. So unfortunately, I have a weird social media handle. Not too weird. Christian H814. So my first name and last initial 814. So now you guys know my birthday, and I expect presents. So go ahead and
there you go.
Send me a tweet. DMs are open.
It's 2002, right? That you were born?
Yes, 2002. No.
All right, get off my channel.
So,
yeah.
And
right,
as
thanks.
always, Chris, please take us home.
Yeah, thank you all. Coming up on the channel here in mere seconds will be an OpenShift Commons briefing talking about building multi-cloud provider platform, Kubernetes. So stay tuned. Thank you all.